So thank you everyone for the nice introduction. And let me start. Let's start to first pull up my slides. 1 second, please. Okay, so yes, as Mr. Tonsing just told, I myself, I am to one side, to one part, I'm employed for BMW, and in that role, for the last 5 years, I've been working very close on the development, the standardization of the CCC digital key. And currently in this role, I do this as the president of the Car Connectivity Consortium, leading the consortium basically to give the CCC, to give the digital key a home in which it's standardized and in which it can be developed. And so today I want to introduce and tell you a little bit more about the CCC, what it's about, what the digital key is about, and a little bit why we did it, and what is the implication for the car security on that. So let me give a quick introduction about the CCC at the beginning in general. 1 second. Okay, yeah. So the Car Connectivity Consortium was established in 2011. It's a consortium. It's a standardization organization based in Delaware, with the aim to connect vehicle industry and smartphone industry for the purpose of generating necessary standards and creating a basis for doing such. And so there's a history about the CCC in which MirrorLink was standardized, which was before other projection technologies was a screen mirroring technology, which used to mirror the screen from smartphones to the vehicle screen. And now the second big item the CCC is working or has been developed is the digital key. The CCC, the Car Connectivity Consortium, is from the membership, just to give you a quick insight, pretty much comprises the whole car and smartphone industry. So almost all the major partners, all the major members are included, and is counting around about 156 members today as of March. What is the purpose of creating a standard for car access? That's the main question. So in the industry, how we used to do it back in the days for the last 10, 20 years, is that every car OEM has its own key, has its own protocols to communicate with the car, and kind of reinvents the wheel or reinvents the key in this case for every vehicle OEM itself. And so as that, there's a non-scalable system which has pretty much a segregated ecosystem between all the cars and keys, which everyone I think is aware of. And so on that, the idea of a digital key is that you have one technology which can every car OEM implement, can every phone OEM implement, and by an easy way, you can create digital keys to access and start cars from one phone, and you can transfer those keys to another phone know, which is what doesn't matter what phone OEM or what company this phone is from, and transfer those keys and access the cars from those other phones as well. And all of that, the biggest constraint or the biggest maxim here is that it has to be at a high security. So what are the main features, or what are the main bullet points the CCC is covering in this digital key endeavor? Basically, one thing, so the one biggest challenge here was to actually get the whole industry together in a consortium to agree on one standard to use for such things. To actually standardize the protocol, which is in this case using NFC as well as UWB in combination with BLE, Bluetooth Low Energy, and get that in a secure way defined, and also certifying the essential parts, which are here based on in some cases common criteria profiles to ensure the security of those parts, and with that create a scalable architecture which can support the deployment of a full ecosystem with this digital key. A question which is absolutely important in this whole discussion is the security. So I think everyone is aware that if you want to have something secure on the smartphone, that this is quite hard, and so there are various attack paths. There are relay man-in-the-middle attack paths. There is the question of confidentiality, so how to make sure that credentials are secure on the device itself, and those things are basically covered in the digital key by the fact that the digital key is required to run on a secure element of the device. And by that, in combination with a direct connection to a connectivity method like NFC in one case and UWB in the other case, the security is achieved to make the digital key basically independent from the RichOS implementation, and as such, giving a basis to actually create a secure key in the device. Just a quick overview, what can you do with that? So what are the standard use cases? It's basically what everyone knows from traditional keys: lock, unlock, start engine, passive entry, then the typical function that you can press a button, remote keyless entry, and additional to this, a digital key also allows termination of a key, to delete a key from a device, the sharing of a key, and also adding or assigning special entitlements to a key, like restricting the usage in terms of speed or whatever the car OEM wants to do. Let me give a quick introduction on the architecture. I think that's what most people in this round here are interested in. So what has actually been done? And in standardization, I think the main objective is to standardize as little as possible, create an architecture which defines which interfaces have to be standardized, and also make sure that you don't standardize things which are not necessary to standardize. And so in this case, what has been standardized is basically two links. So we have here in the middle, we have the vehicle, with its backend, and on the left a friend device, and on the left and on the right an owner device with their backends as well. And all the connections between the devices and the backends and the vehicles and the backends are proprietary, which do not need any standardization. But the interfaces where the two companies actually interface with each other are standardized, which is the direct connection between vehicle and device, as well as the servers. We have this crosslink here from vehicle server to a friend device. This in this picture is noted as non-standardized because it accounts for an app the vehicle OEM runs on the friend device. So of course the app store and how the app is on the device is somehow standardized, but the link itself, the protocol, does not require any standardization. What is the architecture on the device side? So here it gets interesting. As I mentioned before, this is the basis of the security and the basis of an architecture which enables a high security and actually allows also certification for that high security. It's based on the fundament that the digital key itself runs in an applet inside a secure element, which can be properly certified through known common criteria protection profiles, and is directly connected to the communication interfaces, which are used for the distance bounding, which is in this case the NFC, and in our release 3, the UWB and BLE interface. Okay. So let me go a little bit more into detail on the security concept. So the whole system is built as a PKI-like infrastructure. So we have in the servers on both sides, on device and on vehicle side, we have a certification authority, which both sides have chains running down to the device and the vehicle to certify to attest any digital keys or vehicle keys created to be authorized by this CA. And those two CAs in the backends, they trust each other. So this is a first step which has to be done in onboarding any device OEM with a vehicle OEM. And now the most common the most common action we see here, we call it in Ccc Transaction, which is the authentication step between a vehicle and a car, which once the two are already paired, basically create a mutual authentication based on that, create a secure channel between the two devices, between the device and the vehicle, and then transmit the respective command, which basically is the access to the vehicle or the vehicle engine start. I saw there was a question. I will answer them at the end and go into detail with that. So please feel free to add any questions if you have any in the chat, and I will talk to those at the end. So the second step, let me go back to the transaction again. So the transaction basically authenticates the device towards the vehicle. So can make sure that we can be sure that the right device is talking to the vehicle. However, there are known attacks where it's not always sure that the device which authenticates towards the vehicle is actually intended to do so. And in order to ensure this intent by the user, a second measure is necessary, which in the use case of car access and engine start is solved by distance bounding. And so by ensuring that the device which by ensuring that the device which is authenticating is in the near vicinity of the vehicle, you can be sure, as the user of the device is in control of the vicinity of the vehicle. By that, you can ensure that only a user intending to access the car access the car at the end. And this is now done in two different ways. So the digital key has two releases, release 2 and release 3 out, which does that with two different ways. So the release 2 does it with NFC. Everyone's aware that with NFC, only the communication is only done about over a couple of centimeters, and by that can ensure the distance bounding to the vehicle. And problem with NFC though is that for that use case, you always have to pull out the device out of your pocket and hold it towards the door handle. And as such is not the use case exactly what everyone is used to from its keyless go and keyless entry keys. And therefore we also specified a second way, which uses ultra wideband UWB in order to make sure that the device is close to the vehicle. For that, ultra wideband in the IEEE in the year 20, I have to lie, 18 or 19. I think it was fully completed in 19. Added this 802.15.4z standard, in which additional security functionalities were included to achieve that. And so those security functions basically mean that the distance bounding, which is done with a time of flight measurement in UWB, which means the car sends a message to the phone, and the phone responds a message to the car, and now the car measures the time, so the phone tells how much time was between receiving and sending the message, and now the car knows how much time actually the signal was traveling through the air, and by that can define the distance to the device. And attack methods are possible if you actually know the message, because you can send the message earlier to the vehicle. But now this additional technology, which was introduced in 802.15.4z, uses an encrypted message to measure this time of flight. And by that, it cannot be known by attackers and can basically not be attacked. And so the distance measurement, which was introduced here with UWB in 802.15.4z, which CCC is using, is basically a distance measurement which cannot be shortened. So if a device is 10 meters away, because an attacker could, under no circumstances, know the signal before it actually has seen it, and could not transmit this signal faster back to the vehicle than the speed of light, through that, basically, it's not possible to shorten the distance. So much for the distance bounding. To add, to actually be able to do the a transaction in a distance bounding, any key or any device, of course, has to be bound to the vehicle in the first step. And this basically is done by persisting the public key of a publicly secret key pair from the device into the vehicle. And so this is quickly shown in this slide here, how this works. So we have a 4-step approach here. So in the first step, we prepare both device and vehicle. So key pairs are created on both sides, and the appropriate certification chains are generated. in order to attest those key pairs. Then the certificate chains of those key pairs are exchanged, so that the vehicle can actually make sure that the key which it receives from the device is actually an eligible key which has been created in a secure element and has been authenticated by at the top by the device OEM service CA, which the vehicle OEM trusts. And after that authentication of that key, this public key is persisted in the vehicle and is used to authenticate a device further on, using the methods I just explained the slides before. Last but not least, a very important concept is the concept of sharing. So let me give a quick overview about how sharing works in this case. So we have basically we have two devices here, and there is a sharing invitation between the devices, and then a sharing handshake, which kind of in a similar way makes sure that both devices are eligible devices and create their keys in a secure element, which can be attested by the CA. And then in the last step, once this is done and the friend device creates a key which is signed by the owner that it's eligible and that it's allowed to create, that key is then again sent to the vehicle OEM backend to also be checked from the vehicle OEM. Was it an eligible key which is created? Has the user actually activated this function? Does he allow to create those keys? So that the vehicle OEM then can attest this creation of the key as well. And only with that attested new created key going to the vehicle, the two steps which I just showed separately for the owner key generation, then I created the key in the car so that the car can authenticate that the new key is actually eligible, is actually a valid key, and also then can use that key to allow actions on the vehicle, like opening the car or starting the engine. With that, I think the time is already quite far. So so much about the technical detail about the digital key. Let me just quickly sum up with the industry support for that. So the Car Connectivity Consortium currently, the Car Connectivity Consortium is ran by a board of directors. So basically that's the companies which support the Car Connectivity Consortium by also assigning a director, which helps to lead the Car Connectivity Consortium. And you see that the group comprises quite a lot of device OEMs and vehicle OEMs, and the CCC sees a very high involvement by the industry, and I would say that all of those companies here in the list are also amongst many others which are highly active in the definition of the specification as well as the certification of this technology. The consortium is a consensus-based, contribution-driven consortium, which means basically it is open for everyone. So every company can join and can help to define the standards as well as to define the certification. And within the group, it's kind of run like a small democratic country. So it's pretty much every dispute which happens is broadly discussed, and it is envisioned that every difference between different members comes to a conclusion where the technically sound solution at the end is being used. And so in the past 5 years I've been working in the CCC, we had only very few cases where actually a vote would have to had to make the call, and mostly it's done through consensus. With that, I want to thank you, and I can jump into right into the questions, or Mr. Tonsing, do you want to moderate the questions first?
I can do it. For the first, thank you. I say Daniel, thank you for your presentation. And just to mention, I think you are now not located in Germany. You are located in the US, and yes, from there you have presented to us. Thank you for that. So let's go to the questions. I see 4 questions. The first one is. Let me see it from Frank Morgner, Bundesdruckerei Innovation Development. What should I do to read out the question? Where do I see it? A recent study found that many keyless entry systems are still vulnerable today. What the plan to achieve practical security in actual deployed systems?
That is a very good question, and thank you for that. I think it's actually very hard to achieve that in current systems. And we have asked ourselves this question early in the process as well. And the answer we came to, you see today in what has actually developed. And what has developed is that it's a new technology which first involves all the device OEMs to build some extra technology in the devices, and second, to define a new protocol which is completely new from everything what has been existing before. So to answer the question in short, I do not think that it's possible in all ways, and the clean way is, to our understanding, to create something, to create a technology which everyone can use, and achieves the security maxim you were asking here for.
Thank you. A further question, a second question is from Peter Rost from Seconet. I think I must not read the question for everyone. Everyone can read it. And
correct. So the question basically is how to handle the rental car cases. So keys can be assigned with different entitlements. So this includes time. This also includes special rights, and by that it can be perfectly be used for such use cases as well. I do want to say though that time is actually not the critical measure which is needed here. For example, in the rental cases with physical keys, it is similar that today you get a key from a car rental company, and you know the rate, how much it costs per minute, per day, depending on the contract. And you give it back when you want to give it back. And if you don't want to give back the key, it's possible with all rental schemes currently. And that model actually works quite well. So I've heard this question a lot of times. That's why I want to mention that that it seems when you first think about time would be critical, but actually critical is that you are sure when the key has been given out and when it has been returned, that you know how to build that. But actually to time bound it is not the most mission critical functionality on that.
Thank you. A further question is from Franz Brückelmeier from Infineon. Exchange of root certificates to build the trust between vehicle OEMs and device OEMs creates the demands that each vehicle OEMs need to align with every device OEM. Isn't this contradiction the claim every car with every phone?
Also, very good question. I agree with your statement. This stretches this maxim. However, if you want to create a secure solution, so if you want to make sure that only participants which implement it in the right way are eligible to actually create devices, you have to add a certain anchor where you check those companies. And so there are two ways to do that. You can do it centralized or decentralized. So you can announce one entity, which now, for example, gives certificates for all the member companies, and kind of like authorizes those to be part of the system. Or you do it decentralized, that every in this case every car OEM which wants to connect to a vehicle OEM does that distributed and does directly do a key exchange, trusted relation, creates a trusted relationship. And so we in this case we use the second one to do so, knowing that one of the two you have to use, because otherwise you could not make sure that the company or the device OEM, in case of a car OEM, you connect to is how to say is following the rules or following the certifications necessary to provide a secure solution.
Okay, thank you. A further question from Detlef Kraus from SRC. It's about key length. The key length you are using in the PKI.
Okay, the key length. This one, you call me cold feet. I would have to check. So we have designed it in a way that those things are, for the current state of the art, are long enough. So because the key length itself, I think, is not the right answer, or the fully right answer, because it also depends on the cryptology which is used. This one I would want to prefer to please write me an email. I can answer that to you after checking.
Okay.
But I can assure you that it's to the current state, it's a very long length. I remember a lot of discussion exactly about that. Which cryptography to be used, and by that reducing the length of the key to make it a bit faster. But I don't recall it right now what it's exactly. And also, those are things which definitely in future, if necessary, would have to be updated.
Okay, thank you. A last question, perhaps from my side. It's not in the chat. I say it. If I understood you right, the digital key is a digital key pair, which is in a digital key applet, which is in a secure element of a smartphone. This digital key applet, I think it is standardized. Is there only one applet which is offered by CCC to everyone in the system, or each car OEM or whoever has his own applet?
Yes, also a very good question. So the applet, basically the concept of applet basically is relevant for the device. So the vehicle may use its security methods as the vehicle OEM defines, but important is that the vehicle OEM ensures that the device implementation is secure. And here, using one applet definitely would be an option. However, that makes it very hard for this. If the CCC would do that in terms of maintenance, support, and everything, people may device OEMs may have different secure elements, and so all of that would have to be maintained. So we choose a different path here. We do it the way that the applet has a protection profile, a certification. So we defined in CCC, we defined a common criteria protection profile to certify the applet, which is also approved by CC. And through that, make sure that the applet implementation may be different over devices, but in every case is secure to the certification.
Okay, thank you. I say the last chance. Just now a question. I think from Christian Wiebus. I see, where are the keys stored in the car?
Yeah, I see the two questions from Christian. So where are the keys stored? This is up to the car OEM. So the car OEM is responsible for making sure that the key storage in the car is secure. And as of now, every method can be used here, which achieves that. And the last question, if I can just check that also from Christian Wiebus, how does the CCC deal with the fact that cars in the field for 10 to 15 years? That's a good question. So there are many items which need to be regarded here. Let me just point to the most important ones. So first of all, backward compatibility. We built a system which, when it evolutes, the device will still be able to also support older versions of this protocol. And as such, so even if the device updates, the older car implementations can be supported when cars are out 10 to 15 years. And I think the second one is the security. So 10 to 15 years is a long time. If in that time security becomes an issue for the protocols used in that time, then the concept here also allows of deactivating methods, not allowing certain versions anymore, not allowing the keys to be created if ever it comes to the case that, for example, crypto lengths are not secure anymore as they were used 10 to 15 years ago.
Okay, a further question, perhaps the last question, is from Franz Brückemeier, again from Infineon. Is a vehicle manufacturer app required or optional? It's a question relating to the app.
Mm-hmm. So the CCC implementation envisions it this way, that all the core functionality of the digital key is included in the smartphone OEM implementation. And as such, the vehicle manufacturer OEM, as per the standard, would not be required. How vehicle OEMs at the end do this is depending on their implementation, but the standard doesn't require the app to be mandatory.
Mm-hmm. Okay, I do not see any questions. So again, thank you, Daniel, for your good presentation, for your good answers to the questions. What we have achieved is in the moment is looking at the agenda, looking at the time frame. We are in line with the time frame, so that I can switch over. Thanks again, Daniel. To switch over